We are going to learn about federated learning. Federated learning is a machine learning setting that allows us to train models and to analyze data without moving it from its origination place. Let me start from this slide because data is perhaps a thing that is common in a lot of computer science work and in engineering disciplines. We all work for data. Data is almost born on edge. Our computers, smart devices, smartphones, cars, and all smart appliances are generating thousands of gigabytes of data every single moment that we need to analyze. So, with this huge explosion of internet probe in connectivity and in data processing, data is actually very useful thing. We use it to analyze matrices and trends, and we can come up with recommendations, and we can build models to apply data science on it, so on and so forth. Data is also a bit risky as it comes with sensitivity and privacy. Moving data around is actually very energy consuming. To move data back and forth in computers, smartphones, cars, and other smart appliances towards servers needs tons of energy units. The idea of federated learning was born from the question that can the data be born and always remain on the edge? And if somehow we manage to successfully resolve this question, we would be able to meet a suite of AI, machine learning, infrastructure, and technologies such that we do not have to wait to get improvement in services from the service provider. It automatically improves on devices because it trains on data that is trained on the same device. We can save our battery as well. We can use the models and AI even when there is no internet. And most important of all this is that privacy is preserved because data with all the center of information in it is not moving from one device to another. This is the most ambitious probe of federated learning one of the recent definitions of federated learning that data is always kept locally on the same device. It is not moving along the network, rather a small sized data model is being trained and sent towards the central server. Federated learning comes in different flavors. Here we have mentioned two different types of federated learning. One is cross-device federated learning and other is cross-silo federated learning. We have focused in past on cross-device federated learning. In this setting, clients are devices that are phones, laptops, computers, tablets, and all IoT devices. You can imagine that we have thousands and billions of such devices, such that we have a lot of clients. But imagine data per client is very small because each person will generate very small quantity of data. But when we combine all the data generated collectively, it is a ton of data. And the service provider can be a software company that transports data models and provides services and engages in this process of moving back and forth towards servers and towards clients. Other equally popular federated learning setting is called cross-silo federated learning. Silos are essentially containers of data that contains a lot of data and that should always be separated from each other. Here we have example of institutions. These institutions represent network of clients like hospitals. Each hospital may have hundred or thousand of patients and medical records that generate data, and they must be separated in any case. No two hospitals will have shared data. Every hospital have their own data set. Network of schools, advertising companies, these all are examples of silos. We have a lot of institutions and that have their own data, and we are going to train a shared model from their independent data. We are not moving data from clients because there are policies, legislation, and privacy protection laws that prevent data sharing. Now, the major difference between this setting and cross-device federated learning is that here you have comparatively less clients. You can have tens or hundreds or sometimes thousands of clients in this setting. But the clients here are much bigger and much more powerful. For instance, they are not phones, they are not computers, and they are not IoT devices. These are institutions, and each institution might have its own cloud infrastructure, or it may have a bunch of servers in it. Computing power here is not limited per client. Every client in that setting can possibly have many thousands of training examples or millions of thousands of training examples. You might have seen in the classical setting of machine learning that The cloud AI, which is one of the main way of training models using artificial intelligence in cloud, is called distributed machine learning. Here in this example, I have shown that data is acquired by a service provider and there is an engineer of the company that wants to build a training model for the improvement of services. The engineer would submit a request. The engineer typically will not be able to bring data on his computer or on the machine and apply machine learning model. Rather, the data will be dispatched to the server as shown in the slide, and all the computation will happen on the server. And all the servers are also living on the client. The engineer will inspect the model that it is up to the matrices and will decide that whether he wants to stop the training process or not. In distributed machine learning, we are dividing data into parts and sending these parts to different servers for performing AI model training. Federated learning is different. Many people confuse distributed machine learning with federated learning, or they consider it as a part of distributed machine learning, although it's not. There are some similarities that job is not happening on one place, rather on multiple servers. Now we have compared multiple characteristics of different learning mechanisms. In distributed learning, normally model is trained on large data set, but data set is usually flat. Clients are computing nodes that perform the computation using single cluster or from the data center. And then in cross-siloed federated learning, model is trained on siloed data like data from organizations in which multiple organizations like hospitals and financial companies and many other can be participating, or all the clients might be located in different geographical regions also. In cross-device federated learning, multiple devices are contributing in model training process. They can be mobile phones, they can be laptops, they can be other IoT devices, other smart devices. All appliances can be contributing in model training process. In distributed learning, data is centrally stored. As data is centrally stored, so it can be shuffled and balanced and can be distributed across all clients, and any client can read any part of the dataset. In cross-siloed and cross-device federated learning, data is generally located on the device where it is being generated, so data remains decentralized. Each of the clients stores its own data and it do not share its data with other client. Orchestration in distributed learning, data is centrally orchestrized. In cross-silo and cross-device federated learning, the central server organizes all the training process, but it is not possible that server can have access to raw data. It is only training the model. With respect to communication, as data is being kept in a huge database in distributed learning process, fully all the clients are fully connected to the data centers and all the clusters, therefore communication do not take place. In cross-silo federated learning and cross-device federated learning, hub and spook technology is being used, with the hub representing a coordinating service provider and the spook represents the clients. In distributed learning and cross-siloed federated learning, all the clients are almost all the time available. But in cross-device federated learning, some of the devices might be turned off. Some of the devices might not be available at the time of training, or they might be busy. So they might refuse the training round, or they might be available after some time. So data availability is a question mark in the case of cross-device federated learning. All the devices may not participate in every round of training. Distribution scale of distributed federated learning, normally 1 to 1000 clients participate, whereas in cross-siloed federated learning, less than 10 or 100 or 1000 devices can participate, 1000 institutions can participate. In cross-device federated learning, millions and billions of devices are participating for training. Another major characteristic of learning mechanism is addressability. In distributed learning and in cross-siloed federated learning, each client has its own identity and name. So this it allows the system to access that client specifically. In cross-device federated learning, we cannot maintain an index of the client because a lot of clients are participating. So in statefulness, in distributed learning and cross-siloed federated learning, every client will participate in the round of computation and they can participate over and over again. Whereas in cross-device federated learning, each client will participate in the training round only once. So in every round, we can see new number of clients, new members that are training the dataset. And the major bottleneck of distributed learning is the computation ability. The system might not be enough, might not be fast enough, and computation might be slow. In cross-siloed federated learning, computation and communication both can create bottleneck. In cross-device federated learning, communication is the major problem because a lot of devices are uh, participating in the round. All the devices are depending on each other. Federated computation normally uses Wi-Fi and other slow connections. Therefore, communication is creating major hurdle in cross-device federated learning. In distributed learning or cross silos federated learning, it is the clients are normally reliable and failure rate is relatively low. Whereas in cross device federated learning, almost 5% of the clients are normally not available in every round of training. So reliability rate is very low. In data partition, with respect to data partition, we can see that in in distributed learning mechanism, data is partitioned and it can be repartitioned and it can be arbitrarily assigned to any client across between the clients. And in cross siloed federated learning, data can be partition can be fixed. It can be horizontal and it can be vertical. Like the examples, training example can be horizontally partitioned, and all the features of the data can be vertically partitioned. In cross-device federated learning, fixed partitioning is occurring with respect to examples of training grounds, and it is usually horizontal training. Well, dear students, up to now we have seen that how data is generated on the edge devices, how it is transmitted in distributed fashion or in federated learning. Then we have seen different types of federated learning. We have taken an overview of that, and then we have seen multiple characteristics of different learning mechanisms. In the next lecture, we will see in detail different types of federated learning mechanisms. Thank you.